Morning, Year 10, and we're going to look at the electromagnetic spectrum today, and specifically the electromagnetic waves. Now, I have attached the rag sheet for this, so first of all, before we start, I suggest you fill out the initial column and take some time to reflect on the waves after doing the test yesterday. If you haven't emailed me the test, your test scores, let me know, and I will with your class name and your score and whether it was foundation or higher, and I'll email an update, show my homework with your grade. So just a quick recap. Can you just answer questions 1 to 5? Pause the slide now and answer these questions. So question number 1. State the formula. Wave speed equals frequency times wavelength. Doesn't matter which way round you did that. However, you do need to know it. So then number 2, water wave has a frequency of 6 Hertz and a wavelength of 4 meters. Calculate its speed. Hopefully nobody's got to take their shoes or socks off to work that one out. So we do 4 times 6 equals 24 meters per second. A radio wave has a speed of 300, loads of zeros, meters per second. And it has a frequency of 600,000 million hertz or whatever it is. What is its wavelength? It is 50 meters. If in the exam you haven't got a calculator, hopefully you know how to do this. However, all you can do is line them up as if you were doing the tens, hundreds, thousands, units thing and knock off the zeros, and then that would leave you with a significantly smaller number. Okay, please be aware these huge numbers that I can never remember if they're billions or millions are just there to see whether or not you understand that concept. So if the radio wave at the same speed as above has a wavelength of 500 meters, what is its frequency? So what we have is that huge 300 something million thousand number, and divided by 500 equals 600,000. Okay. And then last one, calculate the frequency of a wave whose source makes 12,000 vibrations in 6 seconds. And that is a frequency, a number of waves per second. So you do 12,000 divided by 6 equals 2,000 hertz. So the electromagnetic spectrum. Now, as you can see from the diagram below, it is a spectrum of different waves that have used for different purposes depending on their frequency and wavelength. It is divided into ionizing and non-ionizing radiation, and we'll come back to why that's important in a minute. Okay, so every day we're constantly bombarded with these waves, and you can't feel them; they're invisible. Okay, but they are part of the electromagnetic spectrum, and you do need to be able to recall the order in which they go in, so during a test. So, what are electromagnetic waves? There are 2 types of waves that we study. The first are physical waves, which transfer matter and particles, and these include water waves and waves on a string. Electromagnetic waves, which transfer energy without transferring matter, they share the same wave properties as physical waves, but they behave the same way. We observe light being reflected, refracted, and diffracted in the same way as water waves, and the difference is that we don't see the transmission of the wave itself. Here's my electromagnetic spectrum, okay? And this goes from smallest to largest, and it gives you some examples of which each of them are used for. So the wavelength increases. Electromagnetic waves can appear very different, but they have 3 main things in common. They all travel at the speed of light. They are all transverse waves, and they can all travel through a vacuum. So think about this. You can't scream in space, but the UV radiation from the sun and the infrared radiation from the sun gets from the sun to the earth through space, and space is a vacuum. So this is the order that I would suggest that you remember the electromagnetic spectrum in. And I'll give you a mnemonic in a minute on how to remember this. So fill in the blanks. Pause the slide now. So here's the answers. So we start off with low frequency and high wavelength, moving to high frequency and low wavelength. Okay. Everything travels at the same speed through a vacuum, and different wavelengths are absorbed by different substances. E.g., if you think right back to the physics when you started it in year 9, the black surfaces are much better at absorbing infrared radiation. The absorption may heat up the material, okay, because like microwaves will cause alternating current, like in a TV aerial. Our eyes can only detect a very small part of the electromagnetic spectrum called the visible light spectrum. So more about electromagnetic waves. So moving the spectrum from long to short, energy increases as the wavelength shortens. Now that's really important because, again, you'll see on the earlier slides we talked about ionising and non-ionising radiation. Ionising radiation, it tends to be more dangerous because it has more energy, and they're the ones that can be harmful to our cells because that energy damages the nucleuses and causes permanent changes in our DNA. So, electromagnetic waves are formed by the vibrations of electric and magnetic fields, and this is along two different planes. Now, as you can see from the diagram at the top, the first plane shows the electric field in red, and the second plane shows the magnetic field in blue. Once formed, the energy travels at the speed of light until further interaction with this matter. Now, the person that's really, really key in this is Heinrich Hertz, because Hertz is what we use as a unit for frequency. However, it's worth noting that Maxwell was the first person that discovered this, but it wasn't confirmed with any real scientific proof until Heinrich Hertz did some more research. So here we are. So we've got electromagnetic waves are electromagnetic disturbances that transfer energy from one place to another. There is no matter, is transferred only energy. So what we've got is radio waves, microwave, infrared, visible. Now, we all know the mnemonic for remembering the order of the colours in visible light, and that is Richard of York gave battle in vain. So that's my red, orange, yellow, green, blue, violet. Okay, and it's really worth noting just in your head that the red, it starts with red and it finishes in violet. So the ones that go either side of that are red to the left and violet to the right. Now the mnemonic that I remember used to remember the order of the electromagnetic spectrum is rate my Insta, very unusual X-rated granny. Okay, and it is just a silly thing that I use to put them in order. Okay, now again at the bottom you've got an indication of the size of the waves. So a radio wave is about the size of a building, whereas once we look down to microwaves, which you've all got in your kitchen and your phone uses microwaves, they are the same size as a grain of sugar, and it gets smaller and smaller and smaller. Now everything below, from radio to visible, it is non-ionising. Everything from ultraviolet to gamma is ionising radiation. Now, we can manipulate that ionising radiation to be of benefit. However, it's really important that we know that's where the distinction is, especially for the higher tier. So speed of waves, we're back to an equation triangle. V equals speed, F equals frequency, and lambda equals wavelength. So here's some questions. Have a go at them. Pause the slide now. So the answer to the first one is 200 meters per second, and the answer to the second one is 300 meters per second. Right, what I want you to do is pause this slide now and fill in the blanks for me. Thanks. And this is what it should have looked like filled in. Check your answers, check your work. So key points from today. The electromagnetic spectrum is the order of the decreasing wavelength. You need to remember that sequence in the order that is there. The fact that human eye can only detect 400 to 700 nanometers. Electromagnetic waves transfer energy from a source to an absorber, and the wave speed is the equation. And again, you need to be able to manipulate that. Okay, see you again tomorrow. Bye.